Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today we are going to talk about System D. The system daemon, which is the first user space process in today's Linux, having a PID of 1. It is System D who acts as the granddaddy of all orphan processes. Today most Unix flavors and almost all the Linux distributions like Ubuntu 15.04 onward, Debian 7 and Debian 8, Red Hat Enterprise Linux 7 and CentOS 7. They all use System D. Therefore, System D has replaced the old traditional System 5 init daemon, as well as the short-lived upstart daemon. Before we start digging out information about the system daemon, let me refresh your memory by defining a daemon. A daemon is a long-lived process that is mostly created at the system startup and runs until the system is shut down. A daemon process runs in the background and it is having no controlling terminal. And this ensures that the kernel will never generate any terminal related signal for a daemon. By terminal related signal I mean SIGINT, SIGQUIT, SIGTSTP and SIGHUB. Let's start playing. Okay, let me first check out whether system D is there in the default path of ours or not. Yes, it is there. Let me see the long listing of this. Bin system D. When we see the long listing, we see that /bin system D is actually a soft link to lib system D system D. Let me do long listing of the lib directory, and inside lib directory the system D directory, and inside system D directory system D. Well, yes, this is the actual executable system D, and /bin system D is a link to this. I will also like to show you, for backward compatibility, you have the sbin init still there in your path. You can use this command as well, init, and it is also a soft link to actually lib system D system D. Let me check out by using ps process of ID 1. Okay, so you see that this is the system D process having the PID of 1, PGID of 1, session ID 1, no controlling terminal, statistics, UID, that is root, and swapper is, or the scheduler is the parent of this process. This is the first user space process. And if I see from here sbin init, you can see that this is a link to the actual system D program. So after seeing the system D executable, let us see two more important directories. There are two important directories that are related to system D, which contains the configuration files. They are the lib system D system. This is the directory. Let me less it. You can see a lot of configuration files over here. We soon will see the details of this. There is another directory that is @c system D system. This also contains the configuration files, less number of, and there is another directory that is I don't know whether this directory will have files or not. Run systemd system. This is empty. This is basically the last directory is normally created dynamically by the systemd itself for creating files, configuration files at runtime, and to set the behavior for certain sessions. So we will be more interested in these two directories, the lib systemd system and etc systemd system. Let me clear screen and let me show you an important command, that is systemctl. Well, systemctl is a command that is used to introspect and control the state of the system daemon. You can see the man page at the time of your convenience. Right now, let me give the first command, that is systemctl -t help. It shows you the different unit types which are available for systemd. And there are a lot of unit types, and the first unit type is service. In systemd, a unit is basically a resource that system knows how to operate and manage. And there are different resources and different unit types associated with each resource type. And the first resource type is the service. The service unit files are basically meant to handle daemons. And the daemons are programs that can be started, stopped, restarted, disabled, enabled by the daemon process. Today we will also talk about the target unit files. The target units basically group units together, and they represent the state of the system at any one time. They're quite similar to the run levels in the older Unix systems. Then we have device, mount, and auto mount. They are basically related with mounting of devices, and they have replaced the etc step system of mounting and auto mounting. You have the socket unit file as well, which describes a network or IPC socket. And these socket unit files will always have an associated service unit file that will be started when some activity is seen on the socket that this unit file defines. Okay, so let's start moving ahead, and let me show you the contents of the lib systemd and system directory. Oops, let me less it. So you can see that there are a lot of .service files over here. Other than the .service files, you can see the .target files over here. So basically, when we install the operating system and later we install different softwares on our systems, this is the directory where the unit files are placed by default. One must not edit the unit files located in this directory. If we want to do this, we can do this in another directory, that is the etc systemd directory. This is a place where if we want that we want to reconfigure a particular daemon, we should edit the files over here. Okay, so let me shrink this and let's talk about the target unit files in particular. From the lib systemd system directory, I just want to see the target directories, target target directories. Any file that ends with .target. There again a lot of targets. Let me less this. Okay, so these are the target files. As I have already said that a unit file is basically a configuration file that describes how to manage a specific resource. These target unit files are different from the basic other unit files like service files, because these target files, they don't represent one particular resource. Rather, they represent the state of the system at any particular time. Let me show you some important targets like halt.target, hibernate.target, power off.target, reboot.target, and run level 3.target, run level 4.target. So it appears that these target files are very close to what we normally call the run levels in the older Unix style. Let me see run levels over here. Lib systemd system run level. Okay. Sorry. If you see that we have these 7 links 0, 1, 2, 3, 4, 5, 6. Basically these are the 7 different run levels, now called the 7 targets. If I do a long listing of this to make you understand a bit better, you can see that lib systemd system run level 0.target is a link to a file that is poweroff.target. So this is run level 0. Rescue.target, this is run level 1. We have multi-user.target for run level 2, run level 3 and run level 4. Then we have graphical.target for run level 5, and we have reboot.target for run level 6. So you can observe that each run level is a link to appropriate target unit file in the same directory. For your better understanding, let me man the run level page. You can see it says that run levels are an obsolete way to start and stop group of services used in System 5 init. And previously the run level 0 we have poweroff.target, run level 1 rescue.target, run level 2, 3, 4 multi-user.target, run level 5 is graphical.target, and run level 6 is reboot.target. So please go through this page as well. It is also a bit interesting. And with all the run levels, there is a directory that is run level 1, 2, 3 whatever .target .wants, which contains the name of the services which are wanted by that particular target. Anyway, so let's not go into that depth, that is difficult to understand. Let me show you another command, Systemctl list dependencies. I just want to see the dependencies of a particular target, and the target name is, let's suppose, the graphical.target. So this page shows you a lot of services that are required by the graphical.target. If you want to achieve this target, these services must be up and running. And you can see there are sub-targets as well, basic.target and sockets.target. Let me just grab targets from here for a simple output. Okay. So over here now it's a bit clear. Graphical.target requires that multi-user.target should be achieved, and multi-user.target says the basic.target should be achieved, and basic.target says that paths, slices, sockets, and sysinit.target should be achieved, and so on. So you can imagine that these are very close to the System 5 run levels. And if you want to see or list the dependencies of a smaller target, let's suppose I want to list the dependencies of let's suppose this Getty. getty.target. So you see, to achieve this target, you need to start these two services. Right. So to those students who have seen the previous run levels in Linux, they must have seen the init tab file which used to manage those run levels, and there was a default run level entry in that file. Over here, if you want to set the default run level, you can use Systemctl. Let me first show you the command to check out which is the default run level. So the default run level is graphical.target, and if I want to change it, so the command is set default, and if I press tab twice, I see a lot of list of targets over here. So I just want to say make it multi-user.target, and this ask me for the permissions, and the permissions have been granted, and you have seen that it has done something. It has removed a file, and it has created a file, and it has created a symbolic link at systemd system default.target, which points to now libsystemd system multi-user.target. So this is how it has managed to change the default run level from the graphical target to the multi-user target. Keep a note that the system link, the symbolic link points to multi-user target. Let me repeat this, and let me set the default target to graphical target. And now you see it has removed the previous link, and it has created another link that now points to the graphical.target. So this is how the default run level or default target level is achieved by systemd. And in case if you want to just switch on to another run level or a target while the system is up and running, you can do systemctl, and you can say isolate to that particular, systemctl isolate multi-user.target. This is just because of the typos that I'm unable to type this command. So after having understood the target files, let's move on to the service unit files. Systemctl-t help. So we have talked a bit about the target files. Now let me talk about another unit type, that is the service. Let me do systemctl to list all the unit files that are installed in the file system. So you can see all the files that are installed, and you can see the states of these services, static, generated, enabled, disabled, and what these states means. If you want to check out, you can do man systemctl, and you can search for let's suppose static, one of the state. So these are the different states. You can read it out, but right now I will be interested in two main. One is enabled and the other is disabled. If a service is enabled, that means it will be started automatically on boot, and if a service is disabled, where is disabled? Yes, if a service is disabled, that means it will not auto start on boot. Let me talk about static as well. If a unit file is not enabled and has no provision for enabling in the install unit, okay, let me simplify this for you. Static basically means that the service can't run automatically on boot. So even if you enable a service, and if it is static, it will not be started at boot time. And one more state, that is mask. And if a service is masked, that means the service is completely disabled. You cannot start this service without unmasking it. Okay, the rest you can see the details. Let me systemctl list units, and let me grep dot service. Okay, so this is, let me shrink a bit more. Now let me, it is moving on to multiple lines, that's why it is not very much clear to you. So over here as well, this is also a snapshot that shows you the information about all the running services uh, and the states, whether they are loaded or not and whether they are active or not. Okay, let's move ahead, increase the size so that you can read, and let me use Systemctl to check out the status of a particular service. Status, status of a service like, let's suppose, SSH, secure shell service. And it says that it is loaded, but it is disabled and it is inactive and it is dead. So let me start this service. Systemctl start SSH. Okay. So the system is started. Let me be root so that it should not ask me again and again. Let me do Systemctl and check out the status of SSH now. You see the status is changed now. It says that it is active, it is running, and the time since when it is running, since 17 seconds. The ID of this process, the group, and a bit of information about at what time it has started, on which port it has started. Okay, so let me enable it as well. You see it is disabled. Let me enable this service. Systemctl enable SSH. Now what has happened is, this line is of our interest. Once we have enabled it, you see it has created a symbolic link in etc systemd system directory, which points to the lib systemd system directory ssh.service. This is important. And now if I see Systemctl status SSH, you see it is enabled and it will automatically start once we boot our system. Okay, let me disable it now. And the important point is it has removed that link. Whenever it enable it, it basically creates a link in etc systemd system directory, and once you disable it, it removes that link from that directory. Now dear students, if you know how to check the status of a service, if you know how to start, restart and stop a service, if you know how to enable and disable a service for making it start automatically at boot time, and you know what actually happens in the background when you do it. So after all this, I think there is one more thing that being an operating system student you should know, and that is writing your own service and running it under systemd. Well, in order to write your own service, what you need to do is you need to go through the details of the service files. Let's see the service file. Systemctl, sorry for the typo. Let me cat ssh.service. So this is the file which I need to cat. Remember, I haven't given the absolute path to this. You can give the absolute path, which is of course of lib systemd system directory. So you see it contains some information which might be new to you. Let me open a man page over here. Systemd.unit. So systemd.unit man page from chapter 5 tells you about the unit configuration, and you can see it tells you that it has a lot of unit configuration files like .service, .socket, .device, .mount, and so on. It says that a unit configuration file encodes information about a service, a socket, a device, and so on, and you can see the details. Let me keep things simple for you. Well, remember, gentlemen, all unit files are normally organized within sections. This is the first section, that is the unit section. This is the second section, that is the service section, and this is the third section, that is the install section. So there can be more sections as well. Let's talk about the first section, the unit section. A section is basically denoted by a pair of square brackets with a section name enclosed within. So this is the unit section. The unit section is normally the first section found in most of the files, and although the order of these sections does not matter, but mostly this is placed at the top. This section basically defines the metadata of the unit file and is used to configure the relationship of this unit file with the other. Well, you can see details. These are the directives which you can find under this, and directive normally comes up with the directive name is equal to value. As far as the service is concerned, service section is concerned, this is applicable only to the unit files, service unit files. For the socket unit files, you will have socket over here. For the mount unit files, you have mount over here, and for the auto mount unit files, you have the auto mount section over here. The install section is normally the last section. This is optional normally and is used to define if it is enabled or disabled. So you can all mostly see this install section for the service files. So today we are going to write down our own service, and we will see how we can write it. I have written probably a program for you. Let me cat it for you. Cat from my home directory. From this inside the home directory of root, I think. Root. Let me cd to my home directory. Okay, fine. That's better. Let me cat Arif service1.c. So this is a basic C program that I have written, which creates a file var log arif1.log. Inside the var directory, the log directory, there is a log file which this program will create or open in read write mode. It will create it in append mode. The permissions are 666. Anybody can read and write this file, and after every 5 seconds it will write a string in this file, PUCIT. It's a basic hello world program, hello world service. Now you can understand, if I compile and execute this file, this string will be written after every 5 seconds in this var log file. But I want to run this program as a service, and I want this to be managed by the systemd daemon. So if you want a program to be run as a service or as a daemon, and you want it to be managed by the systemd, for that you must know that a daemon is a long-lived program, as I have already said. It is created at startup and it runs until the system is shut down, and it must run in the background. It must be having no controlling terminal. So you have to manage all these properties within your program. So instead of doing that, let's write down a basic service file for this. And if you want to create a service file for this, let me cp lib systemd system ssh dot. Instead of writing a service file from the grassroots level, let me copy this file to @c systemd system and with the name of let's suppose Arif1.service. So I've just copied ssh.service file from this location and I have placed it in this location. Remember previously I said that whatever you need to do it in @c systemd system directory and not in lib systemd system directory. Let me open this file in @c systemd system arif1.service. So this is the same file which we have seen before. So without going into the details, let me delete the unrequired portion. I'm just keeping a single directive over here, that is description, and that is the brief description of this. Very simple service by Arif Butt. As far as the service is concerned, I just want to keep it simple as well. I just want to keep a type over here, and okay, the type of the service is simple. There are other types as well. Please go to the main page of systemd.service to find out what other types can be there. Exec start is basically the path of the program. So we haven't created the program yet. Let me move on to here. The program was Arif service1.c. Let me compile this program. Arif service1.c, and let me place the executable instead of in my home directory. Let me create it in usr local bin with the name of Arif svc1. Okay, the file is created over there. Let me confirm that by seeing the long listing of that file, local bin Arif service1. Yes, the file is there and it is executable by all. So remember, usr local bin Arif service1. So I need to give the path over here in exec start directive, that is usr local bin Arif svc1. So this is the program which this needs to start, and over here let me keep things simple again. Wanted by, let's suppose, multi-user target. Let it be there. So this is the basic service file which I have just created. Now the next step is, let me save it. Let me check the status of this service now. Systemctl Status Arif.service. You see, I just pressed the tab and it completed the name automatically. Okay, you see that this service is already loaded previously as well. I have created this service before as well. So let me unload that service, or let me change the name of that service. That will be better if I change the name of this service. Instead of Arif service1, I change the name of this service. Let me say MV Arif service2, USR local, just for better understanding so that you see 2. I've changed it. Okay, so over here again, what I am going to do is I'm going to write the new name over here, 2, and let me clear screen and let me say Systemctl Status Arif2 dot. Is it Arif2 service or no? It is not. I don't think. It is Arif1 service. Let me change the name over here as well. MV @c systemd system Arif1 service. Let me rename it as @c systemd system Arif2.service. And let me do it now. Again, Systemctl Status Arif2.service. So you see that this is a very simple service by Arif, but this was the text that I gave in description. Is loaded, it is inactive, it is dead. Let me load it. Let me start it. And let me check the status again. You see it is active and running now. So let me check out that file as well. -f var log, this was the location of the file, arif1.log. You see it is running. After every 5 seconds it is printing a new line in it. So let me enable this service. And you remember that whenever I will enable a service, it will create a symbolic link. It will create a symbolic link in /etc systemd system directory, and it has created a link to this file arif2.service. And if I disable it, you see it has removed that link, and you see the contents are still being written. Okay, let me stop it. Stop this service, and let me check the status. It is inactive now, and if you see that no more strings are being written in that file. Okay, students, I think that is enough for today. Today we have talked about the system daemon, which is a whole new framework that encompasses many components of modern Linux systems. We have seen the 3 different locations where the configuration files of systemd resides. That is the lib systemd system, the /etc systemd system, and the run systemd system. The lib systemd system contains the actual configuration files, /etc systemd system contains the links, and run systemd system is normally used by systemd itself to create the links dynamically for the session management. Well, students, we have also talked about different unit files, which are basically the configuration files, and these configuration files tells systemd how to manage different resources. We have discussed in length about the target unit files as well as the service unit files. If life permits, inshallah, soon I will come with a session about the mount and auto mount unit files, and we will see how they have replaced all the concepts that we know about the /etc fstab and the mtab file. I hope today's session was informative. I wish you all the best. Allah Hafiz and happy learning. जहां का सबात है तुम ही से ऐ मुजाहिदो जहां